Hey guys, Mr. Isley here. So we're on to lesson number 14 in chapter 2b, all about solving linear inequalities, and this is the last lesson. And we're going to be talking specifically on lesson number 14 about how to solve inequalities with the word or. All right, so these compound inequalities with or. So the process for it is really no different, to be honest, than solving a singular inequality, all right? Because it's really like two separate inequalities. They just have this or word that combines them and makes them compound. So the first thing we're going to do is we're going to find our variable and figure out what's being done to it. So it's going to be on the left side, all right, or the right side of the inequality symbol, right? That's going to be the same, all right? Then we're going to reverse that operation by undoing it. We're going to create that to-do to undo list. Now remember, if we end up dividing or multiplying by a negative, that reverses the inequality symbol, right? So by a negative number, right? So no difference there, right? And then last thing, again, reminder, we're going to solve the inequality, right? And then the goal is to get the variable on one side of the inequality symbol and numbers on the other. Now we're going to have to do this two separate times, right? And the steps to solve are never going to be the same from one part of the compound inequality to the other, right? They're going to have their own separate steps to solve. So make sure you look at each one individually, solve it, and then go do the other one individually and solve it. All right, so let's take a look then at these. So example A says 3y minus 5 is a less than negative 8, or 2y minus 1 is greater than 5. So the first thing I want to do is just look at this one on the left. So 3y minus 5 is less than negative 8. So find my variable. Here it is, the y. Figure out what's being done to it. Well, there's a 3 and a minus 5. So if I go and create my little to-do to undo list, I know that they are first multiplying by 3 because that's the closest thing. Then they are subtracting 5. That's what they were doing. So I need to do the inverse operation in reverse order to solve it. So instead of subtracting 5, I'm going to add 5. And instead of multiplying by 3, I'm going to divide by 3. So there are my two steps to solve this half of the compound inequality. So I'm going to do that. So first step, add 5. So underneath where they subtracted 5, I'm going to add 5. And I still have to do it on the other side of the inequality symbol. So I'm going to add 5 right there. I do not do anything with the second inequality at this point. I'm just doing the first inequality. So I know that when I add 5 to a negative 5, that just cancels out. And all I'm left with is the 3y on the left side. The inequality symbol, right, has not changed because all I did was add. And then negative 8 plus 5, that is negative 3. So step 1 is done. So now step 2 says divide by 3. So I'm going to divide by 3 and divide by 3. So I end up with 3 divided by 3 is 1, so just the y. Now I'm dividing, so I need to figure out, am I flipping the inequality symbol? I'm dividing by a positive number though, so that does not change the inequality symbol, so still less than. And then negative 3 divided by 3, 3 divided by 3 is 1, and a negative divided by a positive is a negative. Bad thing happening to a good guy is bad. So I ended up with this on this left inequality, y is less than negative 1, and that's fine. Then I need to go do the right one. I need to do the 2y minus 1 is greater than 5. Well, it's going to have its own steps to solve. So again, I've got to find that variable, figure out what's being done to it. So I see that my y is here on the left side, and it has a 2 next to it, and then it's subtracting 1. Well, again, same idea. I know that the 2 is multiplying y, and that's closest, so that's what was happening first, right? Then they were subtracting 1. So to solve this, I've got to go in reverse order, and I need to do the inverse operation. So the opposite of subtracting 1 is adding 1, and the opposite of multiplying by 2 is dividing by 2. So there are my two steps to solve this one. So first step, add 1 to both sides. So negative 1 and positive 1, they cancel. I'm left with just 2y. Now all I did was add, so that does not change my inequality symbol. And then 5 plus 1 is 6. Step 2, divide by 2. So I'm going to divide by 2 and divide by 2. Well, 2 divided by 2 is 1, so those just cancel, and I'm left with just y, because 1y is the same as just y. Now I divided, but I divided by a positive number, so it does not change the inequality symbol. And then I've got 6 divided by 2, which is 3. So I've solved each one of these independently, as I was supposed to, but they are a compound inequality. So I now need to take this OR and I need to bring it down. And I'm going to put it between them, because that signifies that this is a compound inequality. Y is less than -1 or y is greater than 3. So now I need to find some numbers to put on my number line. Well, I've got -1 and 3, so let's find some numbers kind of in between. I'm going to start with 1. Let's go 2, 3, 0, -1. There we go. So I've got -1 and 3 on there. So then I need to put circles at each one, so at -1 and at 3. Then I need to figure out, are either of them filled in? Well, -1 is not, because no portion of an equals 2 sign. 3 is not, because no portion of an equals 2 sign. Then I want to choose a number in between the two circles. So I choose 1, and I'm going to plug that into each inequality to see if it makes it true. So 1 in for y on the first one says 1 is less than -1. Well, 1 is not less than -1, so that is false. So that means it should be false for the other one as well, but let's just check. So I'm going to plug 1 in here. I got 1 is greater than 3. Well, is 1 greater than 3? No, it's not, so it's false. So that means everything in between the two circles are not answers, which means everything going the opposite directions are answers. They will make this inequality true. So we end up with two circles with arrows going in opposite directions. Well, if you recall back to lesson number 12 when we learned about compound inequalities, we know that compound OR inequalities graphs look like this. They have two circles with arrows going in opposite directions. So my graph is correct. All right, well, I'd encourage you to try example B on your own, then check your answer with mine. So example B says 4c plus 3 is less than or equal to -5, or c minus 8 is greater than -1. So we've got this or there, so it's two separate inequalities, so I have to solve them separately. So let's start with the left one. 4c plus 3 is less than or equal to -5. So first thing I need to do, find my variable, figure out what's being done to it. Well, I see it's here on the left side, the c, right? And I see that it has a 4 and a plus 3. Well, I know the closest thing to c is the 4, and it's multiplying, so they were multiplying by 4. Then they added 3. So I'm going to do the opposite in reverse order. So instead of adding 3, I'm going to subtract 3. And instead of multiplying by 4, I'm going to divide by 4. So there are my two steps to solve. So first step, subtract 3. So I'm going to subtract 3 here underneath the positive 3, and I'm going to subtract 3 here. We do not do anything with this inequality yet. It is its own separate, so nothing to do with that yet. So positive 3 and -3, they cancel. I'm left with just 4c. Now all I did was subtract, so that does not change my inequality symbol. And then -5 minus 3, that is -8. 5 bad guys, 3 more bad guys show up, so total of 8 bad guys. So step 1 is done. Now I need to do step 2, which was divide by 4. So 4 divided by 4 is 1. 1c is the same as just c, so they cancel out, and I'm left with just my c. Now I divided, but I divided by a positive number, right? It does not matter that this 8 is negative on the right side, right? Because I was dividing by a positive, it does not change the inequality symbol. And then I've got -8 divided by 4. Well, let's start with the numbers. 8 divided by 4 is 2. A negative divided by a positive is a negative. Bad thing happening to a good guy is bad. So I ended up with c is less than or equal to -2. So I've solved the first separate inequality, so now I need to do the second. So c minus 8 is greater than -1. Well, only one thing going on with c, which is they are subtracting 8 from it. So in my to-do to undo list, I only have one thing on it, which was they subtracted 8, so I need to add 8. So inverse operation. So I'm going to add 8 to this side, which means I also have to add 8 to that side. Now negative 8 and positive 8, they cancel, and I'm left with just C, and I'm going to bring it down even here with this one, right, just to keep it in line, right? And then because all I did was add, it does not change the inequality symbol, and then negative 1 plus 8 is positive 7. 1 bad guy, 8 good guys show up. And the reason I brought it all the way down to make it even is because, again, reminder, this is a compound inequality, so I need to bring the or down. So I've got C as less than or equal to negative 2, or C is greater than 7. So now I need to go and graph this. So I'm going to start with a number kind of in between. We'll say 2, and I'm going to count by 1. So 3, 4, 5, 6, 7. 1, 0, negative 1, negative 2. There we go. I've got negative 2 and I've got 7 on my graph. So now I can go in and graph this. So again, start with circles at both numbers. So circle at negative 2 and a circle at 7. Then I need to decide, are either of them filled in? Well, negative 2 does have a portion of an equals 2 sign with its inequality symbol, so it is filled in. 7 does not have a portion of an equals 2 sign with its inequality symbol, so it is not filled in. Then I want to choose a number in between these two circles and see if it makes either one of the inequalities true or both. So I'm going to choose the number 2. And I'm going to plug it in. So I get 2 in for C, which is less than or equal to negative 2. Well, 2 is not equal to negative 2, and it is not less than, so that is false, which should mean that it is false for the other one, but let's make sure. So again, plugging 2 in for C, 2 is greater than 7. Is that true? 2 is not greater than 7, so that's false. So that means everything in between the two circles are not solutions, which means that everything going in the opposite directions of each other would be solutions. And remember, with compound or inequalities, it should always be two circles with arrows going in opposite directions. So that is correct. All right, well, we've got one more example here we want to take a look at. I'd encourage you to try this one on your own, then check your answer with mine. So example C says 2p plus 1 is less than negative 7, or 3 minus 2p is less than or equal to negative 1. So first thing I need to do, I know it's an or, so I need to start with the left compound, or the left inequality, and figure out what's happening and solve it. So start with the variable p, it's on the left side. I see that they are multiplying it by 2 and they are adding 1 to it. Well, what happens first? Well, first they're multiplying it by 2. So that 2 right in front of the p tells me that. Then they added 1. So there is what they were doing. I need to do the opposite operations in reverse order. So instead of adding 1, I'm going to subtract 1. And instead of multiplying by 2, I'm going to divide by 2. So there's my steps to solve this one. So first step, subtract 1 from both sides. So underneath where they added 1 and underneath the negative 7. So adding 1 and subtracting 1 cancels out. I'm left with just 2p on the left side. Now all I did was subtract 1, so that does not change the inequality symbol. And then negative 7 minus 1, 7 bad guys, 1 more bad guy shows up, so that makes negative 8, or 8 bad guys. So step 1 is done. I've subtracted 1, so now I need to divide by 2 on both sides. So again, 2 divided by 2, that's 1, so all we're left with is the p. Now I divided, but I divided by a positive, so that does not change my inequality symbol. Then I've got negative 8 divided by 2. Well, let's start with the numbers. 8 divided by 2 is 4. And then a negative divided by a positive is a negative. Bad thing happening to a good guy is bad. So p is less than negative 4. All right, well, I've solved the first separate inequality, so now I need to do the second, which is 3 minus 2p, which is less than or equal to negative 1. So let's find our variable. Here it is, p. Now what's happening with this? Well, it looks a little bit more complicated. So let's really think about what's going on here. Right? Well, the closest thing that I see to the p is this -2. Now, there's no symbol in between, so that means that they were multiplying. So they were multiplying by a -2. That was the first thing they were doing. Then I've got this 3 here. Well, what is that 3 doing? Well, what we really have to think about is it was out front, and we need to look at the sign that's in front of it, because that's actually the indicator of what's going on with it. Well, 3 doesn't have a sign in front, right? Which means it was a positive number. So it really was adding to the -2p. Now, a lot of times we think it's subtracting because we see this subtraction symbol. But what's really happening is this is being added to the -2p. We could write this as -2p plus 3, and it would mean the exact same thing. Right? So if it helps you to do that, then go ahead and do it. Right? But I can just remember that, so I know that they were multiplying by -2, then they were adding 3. So my step to solve, in reverse order, instead of adding 3, I'm going to subtract 3. And instead of multiplying by -2, I'm going to divide by -2. So there are my steps to solve. So I'm going to first subtract 3. So underneath where the positive 3 was, I'm going to subtract 3. And underneath -1, I'm going to subtract 3. So 3 minus 3, that cancels. I'm left with just -2p, because the negative comes down. Now I subtracted, so that doesn't change my inequality symbol. And then -1 minus 3, 1 bad guy, 3 more bad guys show up, so total of 4 bad guys, so -4. So step 1 is done. Step 2 says divide by -2. So we're going to divide by -2. Well, -2 divided by -2 is +1. So, and as we've talked about, anytime you divide something by the same number it's multiplying by, those cancel. So I'm left with just p. Now I am dividing, so I need to decide, does that reverse my inequality symbol? Well, I'm dividing by a negative. So that means it flips the inequality symbol. And so instead of less than or equal to, it becomes greater than or equal to. And then I've got -4 divided by -2. Well, let's start with the numbers. 4 divided by 2 is 2. And a negative divided by a negative is a positive. Bad thing happening to a bad guy is good. So p is greater than or equal to 2. Well, last thing I need to do, because this was a compound inequality, I need to bring my OR down to separate the two inequalities. So p is less than -4, or p is greater than or equal to 2. So there is my simplified inequality. So now I need to go in and graph it. So I've got -4 and 2, so let's choose a number in between. So I'm going to go 0. I'm going to say 1, 2, 3, 4. -1, -2, -3, -4. So there are my numbers. So now I need to go in and I need to put circles at the two numbers that I know, which are -4 and 2. Decide, are either of them filled in? Right? Well, -4 does not have a portion of an equals 2 sign, so it is not filled in. 2 does have a portion of an equals 2 sign, so it is filled in. So 1 is filled in, 1 is not, and that's fine. Then I need to choose a number in between. So I choose the number 0, and I'm going to plug that in to see if it makes it true. So 0 in for p says 0 is less than -4. Well, is that true? No, that's not true. That's false, which should mean that it's false for the other one as well, but let's check. So 0 in for p, 0 is greater than or equal to 2. Well, 0 is not equal to 2, and it is not greater than 2, so that is false. Excuse me, I almost wrote true. So that is false. So they both were false, which means nothing in between here is a solution. So that means I should have arrows going in opposite directions. And again, if we remember, compound OR inequality should always be two circles with arrows going in opposite directions. All right, well, this was our last lesson in Chapter 2b, so if you have any additional questions, please let me know. Just remember with compound OR inequalities that you have to solve each inequality separately. The steps are going to be different, so use your to-do to undo lists, right? And then always make sure your final graph looks like two circles with arrows going in opposite directions. Again, if you have additional questions, let me know, but otherwise, you should have what you need to finish up the chapter.